Out there, where the sun is little more than a distant star, lies a frozen frontier humanity once thought unreachable. In 2015, New Horizons shattered that barrier, transforming Pluto from a blurry speck into a world of icy mountains and a heart-shaped plain. Yet, the voyage pressed on into deeper darkness, capturing Arrokoth, a cosmic snowman frozen in time. Tonight, we unravel those images and the secrets they hold. When NASA launched New Horizons in January 2006, it was more than just another space probe. It was humanity's slingshot toward the Kuiper Belt, a frontier of icy bodies orbiting billions of miles from Earth. For decades, Pluto had been a blurry smudge, downgraded from planet to dwarf planet, and often overlooked. Many thought a mission there was too ambitious, too costly, too far-fetched. But New Horizons wasn't just a spacecraft, it was a messenger, traveling at 36,000 miles per hour, the fastest launch speed of any probe ever sent into space. Its job was simple, yet impossible. Fly past Pluto after nearly a decade-long journey, capture data in just a few hours of closest approach, and beam it back across the void. Every detail mattered. The instruments had to survive the cold of space, the timing had to be exact, and there would be no second chances. What made it incredible was that all of this was accomplished with technology from the early 2000s. The probe's computer had less processing power than a modern smartphone. Yet, with precision and determination, New Horizons became the torchbearer of exploration. And after 9 years of silence, New Horizons finally crossed the threshold into the unknown. On July 14, 2015, the silence broke. For the first time, Pluto came into focus. Gone was the faint fuzzy blob we'd seen through Earth's telescopes. In its place appeared a dazzling complex world. Mountains of ice towering like the Rockies, vast nitrogen plains stretching farther than the eye could see, and a mysterious heart-shaped scar etched across its surface. This image alone shocked scientists and the public alike. Pluto wasn't a dead rock at the edge of the solar system. It was alive, dynamic, and intricate. The heart, later named Tombaugh Regio after Pluto's discoverer, Clyde Tombaugh, became an instant symbol of planetary beauty. The excitement wasn't just scientific, it was emotional. Across the globe, millions watched in awe as the first high-resolution portraits of Pluto appeared. Children who had once learned Pluto was too small, too distant to matter, suddenly saw it as a vibrant world with a story worth telling. But that heart was only the beginning. Pluto's surface told a story older than Earth itself. Tombaugh Regio wasn't just symbolic, it was a scientific revelation. The left lobe, Sputnik Planitia, is a massive basin filled with frozen nitrogen, carbon monoxide, and methane. Unlike Earth's frozen lakes, these ices shift and flow, forming giant cellular patterns across the surface. Each cell, up to 20 miles wide, rises and falls slowly as nitrogen ice churns like a planetary lung. The lack of craters stuns scientists. If Sputnik Planitia was young and evolving, Pluto was geologically active, something few predicted for a small, icy world. Some models even suggest a hidden ocean might lurk beneath, insulated by nitrogen ice and warmed by radioactive decay in Pluto's core. This discovery overturned long-held assumptions. Worlds this far out were thought to be frozen and inactive, relics of the early solar system. Instead, Pluto reshaped itself in slow, icy breaths. Pluto's mountains, at first glance, resemble the Rockies or Alps, but these weren't made of rock, they were water ice, strong enough to form icy peaks rising 11,000 feet high. Named Norgay Montes and Hillary Montes after the first climbers of Everest, they became dramatic landmarks of the outer solar system. Think of it like standing at their base, sunlight dim, the sky a twilight blue-black, and towering above you an alien mountain of frozen water gleaming faintly in the cold. No atmosphere to carry sound, no wind, no birdsong, only eternal stillness. Some peaks appeared capped with bright methane ice, sparkling like frosted glass in pale sunlight. This suggested atmospheric interaction, methane gas freezing onto the summits, crowning them with glittering caps. Even in the most desolate places, nature crafts beauty beyond imagination. As New Horizons swept past, it turned towards Pluto's edge, capturing a breathtaking sight, a thin, delicate blue haze encircling the planet. Pluto had an atmosphere, faint, fragile, and ephemeral. Mostly nitrogen with traces of methane, it stretched 100 miles above the surface, scattering light in Earth-like shades of blue. But unlike Earth's, Pluto's atmosphere is fleeting. On its long 248-year orbit, it can freeze and collapse, snowing nitrogen back onto the surface. Pluto, in a sense, breathes, exhaling an atmosphere near the Sun, inhaling it again in the dark. The haze wasn't uniform. Images revealed multiple stacked layers glowing with an ethereal blue light. These layers hinted at complex chemical reactions high above Pluto, creating organic compounds that drift downward. Pluto wasn't just frozen, it was a laboratory crafting chemistry that echoed Earth's primordial skies. And Pluto was never meant to be the end. Mission planners always dreamed of pushing further into the Kuiper belt, where billions of icy bodies orbit like cosmic fossils. After the flyby, New Horizons adjusted course for a second encounter. Its target was tiny and faint, known only as 2014 MU69, later named Arrokoth. Roughly 4 billion miles away, it was pristine, untouched since the solar system's infancy. Guiding New Horizons there was like hitting a bullet with another bullet across billions of miles. Yet, in January 2019, the probe succeeded. This feat proved not only engineering brilliance, but the audacity of human curiosity. By this time, we hadn't just visited Pluto, we'd leapt deeper into the solar system, chasing an ancient body never before touched by sunlight. Arrokoth, at first glance, looked playful, like a cosmic snowman drifting silently in space. About 22 miles long, it consists of 2 lobes fused in a contact binary. This shape was no accident. It revealed how dust and rock gently clumped in the solar system's earliest days. Unlike Pluto's rugged terrain, Arrokoth's surface appeared smooth and unscarred, undisturbed for billions of years, a perfect time capsule. Its reddish hue came from tholins, organic molecules formed when radiation bombards simple ices. Arrokoth was a recipe of planetary creation, preserved since before Earth was born. Most remarkable was its gentleness. The 2 lobes hadn't slammed together violently, they had merged slowly, delicately, like snowflakes touching in the dark. Arrokoth showed that the building blocks of planets formed not through catastrophic crashes, but quiet, patient unions. Arrokoth wasn't just a curiosity, it was pure evidence. Its undisturbed surface and contact binary shape supported the idea that planets formed through gentle accretion. Instead of chaos, the solar system's birth was more delicate and graceful than once believed. Every ridge and curve whispered stories of a past written in ice and shadow. Even its orbit told a tale, stable and distant. It had avoided disruption for billions of years. Studying it gave scientists a rare chance to compare reality with their models. Abstract theories became tangible. For the first time, they could point to Arrokoth and say, this is how it truly began. The images of Pluto and Arrokoth did more than satisfy curiosity. They redefined our place in the cosmos. Pluto showed that even tiny, distant worlds can be geologically active, with mountains, glaciers, and possible oceans. Arrokoth showed how planets begin, clumping quietly in the cold. Together, they proved the Kuiper belt isn't just a graveyard of frozen rocks, it's a laboratory of cosmic history. If such worlds exist at the edge of our system, what wonders might orbit distant stars? Could similar icy bodies harbor the ingredients for life? These discoveries also deepened our understanding of Earth. By studying Pluto's ices and Arrokoth's building blocks, scientists gained clues about our own planet's origins and the chemistry that might have sparked life. These distant worlds are mirrors not of what we are, but of where we came from. In the end, New Horizons did more than send back pictures. It reminded us that exploration isn't about conquest, but curiosity. about chasing shadows across billions of miles just to see what's there. The images of Pluto's heart and Arrokoth's snowman shape now belong to all of us, symbols of a species willing to dream beyond limits. Even now, New Horizons pushes deeper into the Kuiper belt, scanning for whispers from unseen objects. Though its power slowly fades, the probe continues to send data that will take years to unravel. Exploration, it's not a moment, but a continuum, a line stretching outward into infinity. Someday, when explorers venture even further, perhaps to the Oort cloud or beyond, they'll look back at Pluto and Arrokoth as the moment humanity truly began its voyage into the dark. For now, Pluto and Arrokoth drift silently at the edge of the sun's domain, frozen, patient, eternal. But thanks to a small spacecraft launched from Earth nearly 2 decades ago, we see them not as distant shadows, but as living chapters of our story. Because sometimes the greatest adventures aren't found in distant galaxies, sometimes they're waiting right next door. So, if you've enjoyed exploring the edge of forever with us, don't forget to like this video, subscribe, and ring the bell, so you never miss the next leap into the unknown.